Okay, here's a video for the Module 4 Part 2 test. Obviously, the retest will not be this version. Number 1, Michelle and Rashid love to go on long bike rides. Every Saturday they have a particular route they bike together and takes 4 hours. Below is a piecewise function that estimates distance in miles they travel for each hour on their bike ride. During which interval of the bike ride are they traveling the fastest? That has to do with slope. And in point slope form, the slope is this number here. So this biggest number there is 16. So this is the interval. So that would be in between 3 or 4 hours. Or you could just copy it as is and then put it in a complete sentence. So you would say during the interval of that. During which interval of the bike ride are they traveling the slowest? Well, that would be the 10, because that's the smallest number. So that would be in between this interval, and again, you'd write your answer in a complete sentence. C, how far have they traveled after 2 hours? Well, you would need to input the number 2 to the proper equation. So I see 2 in this equation and in this equation. This says or equal to 2, which means 2 belongs in this equation. So if I input 2 here, whatever I get is going to be the answer. 2 minus 1 is 1. 1 times 12 is 12. And 12 plus 14 is 26. So you would say in a complete sentence they have traveled 26 miles. What does f of 3 represent? So f of 3, well, let's figure out what that is. This is 3, or equal to, so I would put 3 here. So f of 3, 3 minus 1 is 2, 2 times 10 is 20, 20 plus 16 is 36. So you would write f of 3 as 36, and that means that after 3 hours they have gone 36 miles. What is the domain of the function? Domain is what can x be? So the smallest thing x can be is 0, and the biggest thing it can be is 4. And those brackets mean that 0 is included and that 4 is included. What's the maximum value of the function? A lot of people on this part just put 5. Must be precise. That is the point 2 over and 5 up. What is the minimum value of the function? That would be 5 over and 4 down. That is the lowest point and that is the highest point. During which interval is the graph constant? That's unchanging, so it's staying at 3 at that interval, and that is written like a domain on x, so it would be in between those two, so it would be constant from -1 to 1. There's an open dot, though, on -1, so that would be a parenthesis, and also a transition point is also a parenthesis. -1 to 1, we only put brackets at endpoints with solid dots. During which interval is the graph increasing? Well, our increasing portion of the graph is right here. So what is that? That would be from here to here. So that would be from 1 to 2. And those are both transition points, so I put parentheses. And again, it would be more accurate to put the graph as increasing from 1 to 2. So write it out in a complete sentence. E, during which interval is the graph decreasing? Well, the graph, this is getting a little marked up here. The graph is decreasing from here to here. So that for x is from 2 to 5. So 2 is a transition point, but 5 is an endpoint with a solid dot, so it's a bracket. Okay, moving on. Use proper notation and find the inverse of the function algebraically. Okay, this is really the heart of the unit. So we learned 3 things to do this. We make your function notation y, and then we switch x and y, and then we solve for y. So we have to do inverse operations. The inverse operation of square root is squared, so I'd have x squared is equal to y plus 9, and then I'd take away 9 from both sides, and I would have x squared minus 9 is y. So to truly get this right, I would write k -1, x is x squared minus 9. This is inverse notation. That k -1 means that it is an inverse. So that's what you would write here. Okay, our next one, I'm going to do the same thing. And then I'm going to switch x and y. And now I need to solve that for y. First thing I would do is do the inverse of divided by 3, which is multiplied by 3, which would give me 3x equals y minus 2. And then I would add 2. And then I would write it j negative 1x is 3x plus 2. Okay, tough one now. So we're going to have y equals negative 2/3 x plus 5. I'm going to switch my x and y and solve for y. So I'm going to take away 5. And here's where this went wrong for a lot of us. So we need to divide both sides by negative 2/3. But what I like to do is break it down piece by piece. So I think of this first as divided by 3. So I would multiply both sides by 3 and just take it one piece at a time. And all that did was it got rid of the divided by 3, and I multiplied the opposite side by 3. And then all I have to do is divide by negative 2, and that's good enough for me. And I would switch this back to inverse notation. Graph the inverse of the function on the same axis as the original. So remember, this, if it is an inverse, is going to reflect over this line. And the way that we do that, instead of eyeballing it, we write down some key points on the line. So points where that line crosses real nice and is spread apart, so it can give me an idea what the whole thing looks like. So I start thinking about, okay, well, what points are those? And we did pretty good on the test on this as a class. Negative 3, negative 7, negative 2, negative 4. This one right here is 1, 5. And then the next one is 2, 8. So the inverse of that is going to be all of those switched. And if I graph those, you'll see how it will perfectly reflect, hopefully, over that line. So negative 7, negative 3, negative 4, negative 2, 5, 1, and 8, 2. And sure enough, there it is. And it reflects over that blue line. And you'll do the same technique with B. I'm not going to take the time to do it because I don't want this video to go too long, but you would choose points like this, write them in a table, switch them, and graph. Explain 3 ways you can find the inverse of a function using a graph, a table, and an equation. We talked about all that during the video. 6, Sabrina leaves her house in the morning and goes to school. On her way to school, she passes at McDonald's, a Safeway, her best friend's house, and arrives at school. At the end of the day, when she leaves school, what does she do on her way home? Order matters. How does this question relate to what we've been learning in class? So she would do all of those things in reverse order. You'd list them in reverse order because that's what she would do on her way home. It works as an inverse because the inverse is doing the same set of things in a reverse order. Okay, so you could use that as an explanation on that one, and we did pretty good on that question too. Okay, so hopefully this helps, and I just encourage you to maybe Google Khan Academy videos on inverse functions before taking this retest. Thank you.